Start करो हो जाते start from the very beginning start. Okay. Hello everyone. Good evening. Uh, to all the live stream members. Now I am doing that. It is the second class in our current module, bivariate analysis. In the last class, my friend has told you what is bivariate and bivariate data and bivariate frequency distribution. Mainly, it's a notion. So I am giving you the basic recap of the previous class and some mathematical portion. So you can see the screen here. What is written in here? Bivariate analysis, and there is fixed n individuals. I have to say fix n individuals and collect. I have to collect two data on two variables. As you see, bivariate, bi means two and variate means variables. So we have to collect two data on two variables simultaneously. Otherwise, it will be univariate data sets. So the word bivariate is used to describe situations in which two variables are observed on a group of individuals. Data on two variables recorded simultaneously on a group of individuals is just called bivariate data. That is, after I have set two data like height and weight of 100 adult persons in a locality, and I have told you to that collect the data from those persons, then the group of data will be the pairs will be known as bivariate data, and the individual data like height and weight will be considered as univariate data, as you have done already in class 11. So there is three examples. See there, height in centimeter and weight in kg of 100 adult persons in a locality. I have written something in bracket. So in the previous class, you already know that there will be some proportional or inversely proportional, like my friend has told you that there is some friendship or some eneminess in those data sets. Or so what is friendship and eneminess in data set? Like if you in general consider that the a person is very tall, then it is in general that he will have more weight than any shorter person in general. So that is there is a positive relation of friendship. Like if height is more, weight will be in general be more, and if height is less, weight will be in general less than the taller persons. That is they are proportional to each other. If height is more, then weight is more. If height is less, then weight is less. In the second example, what I have written that industrial production and number of strikes and lockouts with respect to 40 years. So industrial production means the production you happened in all those factories, and number of strike means that is no workout, no work on that day or lockouts. So if I consider that 40 data on 40 years, that I have seen that, or we can easily understand that number of strikes. If number of strikes will be higher, then production will always be less, since there is now lesser number of work days, lesser number of work culture, poor work culture more rather. So there will be industrial production will lesser than those factories where number of strikes and are less, number of lockouts or in that locality will be less. Then there is a relation of eneminess. If production is more, then you have to consider that number of strikes on that factory or number of lockouts on that factory or locality will be less, and vice versa. That is, if number of strikes will greater day by day, then there will be a very negative impact on industrial production. So they are inversely proportional. That is, in production is more, number of strikes is less, or number of strikes is more, then production is less, obviously. And in the last example, what I have written here, that height in centimeter and marks in mathematics of a group of students. So, is there any relationship between height and marks? That is, if you are taller, then you have to get good marks in mathematics, and if you are shorter, then you can't get any good number in mathematics. So this is this is wholesome nonsense. There is no relationship between these things. That is, if height has to be, there is no relation of height to affecting your marks in mathematics. So there is no relationship. But still, this is a bivariate data set. That is, I have collected, say for example, in your school, I have collected 100 students, and I have collected the data of their marks in mathematics in madhyamik examination and height in centimeter, and I have get the data points. I have get the n pairs or say 100 pairs of data. But is there any relationship between those factors or those variables? No, there is absolutely no relationship. So these are the three types of example I have written here. In general, I have considered all those types of bivariate data if there is proportional or inversely proportional or there is no relationship. So next I have come to bivariate frequency distribution. My friend has already told you that by bivariate frequency data, I have just collected here an example. I think the 20 data set is now visible to all of you. So I have collected height in centimeters and weights in kg of 20 adult males, though 20 is very less number in case of statistical data, but due to showing here, I have considered the 20 examples. So you can see here that there is height corresponding to serial number 1 or person 1. I have height 151 centimeter and weight 45 kg and so on. So what I have to do here, I have to construct a frequency distribution table. In class 11, we have already seen that we do frequency distribution of classes of univariate data sets or everything else. So I have considered this thing as a bivariate data set, but now I am considering the parts as univariate data points, and I have separately calculated those things. Like for height, what is the maximum value? You will see in later in this note I have given in this YouTube live stream comment box. And so for height, maximum value is 180 centimeter, minimum value is 142 centimeter. So what is our range? Range is 38 centimeter. There is nothing to tell you. You already know this in class 11. So take 4 classes of equal width. This is nothing conventional. I have just written 4 classes of equal width to make the group looking good. So range of class by number of classes equals to 38 by 4 centimeter equals to 9.5 centimeter. So one takes class width of 10 centimeter. Similarly, for weight in kg, I have maximum value 79 kg and minimum value 40 kg. Range is 39 kg. I have convinced that 5 classes of equal width, then range by number of classes equals to 7.8. So one takes class width equals to 8 kg. So in these univariate data points, like you have done in your 11, that is height, and it will be weight. I have misplaced this thing, and sorry for that. Consider it as weight. Then what you will do in your previous classes, like class 11, you take height and then you consider those class marks like 142 to 151, 152 to 161, like those, and here 40 to 47, 48 to 55, and so on. Now in from my data points, I have gotten that like 151 and 45, the pair will be in 151 means it will be from first, and 45 means it will be from first. So this is 1 column, 1 in the 1 box it will there, and so on. I have completed all those tally marks in here in this table. Now what I have to do from your previous experience, that after collecting the tally marks, after getting the data, we will consider those things in the numerical value. So here we have also done the same thing, height and weight. So it is bivariate data point, bivariate data table, that is bivariate frequency distribution. You have got that 142 to 151, 40 to 47 have 3 people there, and so on. In like 172 to 181 centimeter height have a weight of 70 to 79, the 5 persons there. So likewise, I have seen that this is the bivariate frequency distribution of height and weights in of 20 people. So this is looking very vacant due to very small number of data sets. So if you consider is more, it will be a looking good thing. Now I have to tell that what is marginal distribution. My friend already has told you that what is marginal distribution. So marginal distribution is basically I have taken the bivariate data to univariate data. That is, I am shifting from bivariate data to univariate data. Like if there is bivariate data of height and weight, then I have to consider only the height portion. Then what is the height thing? That is, if I ask you that I have 20 data points of 20 adult males of height and weight. So now I have told you that if can you tell me what is the height? How many people are there in the height range of 140 to 151 cm? So you from this bivariate frequency distribution, you can easily tell that from in the 140 to 151, they have 3 people in this range, 2 people in 48 to 55 range. There is no people in 56 to 61, and 60 to 69. There is 1 people. So in the whole thing, that is from 142 to 141 centimeter, we have a sum of 3 plus 2 plus 1. That is total 6 number of people. So this is the marginal distribution of height. Marginal distribution means I am summing up the weight points, that is I summing up a fixed variable, and then I am telling that height and so on. Like if I consider the height as summing up the height, I can also get the marginal distribution of weight. Like in the 48 to 55, I have asked you the same question, that what is the people of having weight 48 to 55 kg. You have to say that there is 142 to 151 having 2%, 150 to 161 having 1%. So there is 3% in these data sets of for having weight 48 to 55 kg. So from the bivalent frequency distribution, if my notion is to take only the height portion or only the weight portion, that is, if I consider two variables x and y, then I have focused only on the variable x or variable y. I have to consider the marginal distribution of that particular x and y, and you are easily seeing that if this is grand total, it comes from all obviously marginal distribution of height and marginal distribution of weight. So, if in their question arises, what is bivariate frequency distribution of any class? So, you have to write that is class intervals corresponding to height and weight together with their corresponding bivariate frequencies. Define the bivariate frequency distribution of height and weight. So, moving part, what is scatter diagram? Scatter diagram means you already have diagrammatic representation in your class 11 course, like bar diagram, histogram, column diagram, etc., etc. This scatter diagram means that I have taken at least 50 data sets here. You can see that there are so many dots in this figure, or in this, consider it as a graph figure. Then there is in the graph paper, there are so many data sets. Like I have collected those data sets from what happened in horizontal axis, that I have plotted height in centimeters, and what in vertical axis that I have plotted weight in kg. So I have collected 100 adult males data set of height and weight. Then I have plotted those data. Likewise, you can see I have highlighted a point, that is the point showing that the person has height of 175 centimeter and weight of 68 kg. I have plotted that man in this figure. So you can consider that all those points giving us a story. Like the upper point, I have pointed the cursor on this point. Like we having the height will be something around 78 to 75, or having height here will be 180 to 182 centimeter approximately. I am telling you that this all points are giving us a story about their height and their weight. So I can getting a scatter diagram is a diagrammatic representation of bivariate data. That is, you have 100 data sets like in tabular form, like this serial number, height and weight. But this is very spurious to analyze, or very spurious to understand for a layman. So what I am doing here, but what the statisticians do here, that is they plotted those points. Likewise, in univariate data sets, they also considered bar diagram, subdivided bar diagram, etc., etc. So in bivariate data point, we consider it as a scattered diagram. Scattered diagram means that this is diagrammatic representation of bivariate data. Suppose we are given n pairs of values of variable x and y here. X represents height and y represents weight in kg. One takes two perpendicular straight lines as axis of reference. No need to tell that, you have already learned in your 11 mathematics and statistics classes. Now the variable x is taken along the horizontal axis and the variable y is taken along the vertical axis. Each pair of given values can be plotted in a graph paper. Likewise, I have plotted all those figures in graph paper. All those points are giving us a story of their height and their weight. So now the figure obtained when all the n values have been plotted is called as scatter diagram or dot diagram. You can see that we are giving these dots. So it can be represented by, it can be said as dot diagram, as well as this scatters the whole in the whole graph paper. If there is more data, you can see there this will consider taken the whole graph paper and being data and data and only data. So this is also referred as scatter diagram or dot diagram. So I have done the scatter diagram portion, but what is the purpose? What is the purpose of doing a scatter diagram? We all do everything in our purpose, otherwise we can't do anything. So what's the purpose of scatter diagram? Scatter diagram means I have plotted all those data. What is the problem if I fix in the table only? So the problem is, if I consider it as a layman, that hey sir, if I am telling you that this height will grow as much, that is height is more of having weight more, and having the height less is implies that there will be lesser weight in general of those persons. But from the table, the person will two different ideas. So what is nature? Nature means that I have just
stop karo. Okay, continue করতে পারো এখন, continue করো.
Okay. So where am I? I was
Continue
questioning that.
continue Akash.
What is nature and what is degree? So nature refers to the fact whether the two variables are having linear relationship, non-linear relationship, etc., etc. Likewise, in these figures, you can see that in A there is a thing like linear like relationship, whereas B is something non-linear. So I have taken these two examples from the data points, like consider two sets of bivariate data x and y and x dash y dash observed in like linear relationship. That is, lower the x, lower will be the y, and higher the x, higher will be the y. But in this picture B, I have nothing guaranteed that whether if x is more, y will be more. Like in the right hand side of the data set, we have seen that x having largest most value, but y having not so minimum not so large value. Is simply in this middle point I have maximum y value, but it doesn't ensure that x value will be in general maximum. So these kinds of relationship we are getting, that whether it is linear or non-linear, that is the nature of the relationship between two variables x and y. Now, the second question, question 2 arises about what is the degree? What about the degree? If I am telling you that students are obedient, now I am telling you that who is more obedient, but or who is more obedient in which classes? That is, I have classified a particular part into two different parts. Into I am measuring the intensity. What is the intense of the obedience of your people? Similarly, like considering the example C and D, I have considered the both relationships are like linear. That is, lesser the x value, lesser the y value, more the x value, more the y value. Similarly, in D case, lesser the x value, less will be y, and more the x and more will be y. But you can easily see that C, the data points are very strongly clustered around a thin like structure or a straight line. But in D, this is, if I consider it here a straight line, then you can see that the points are very dispersed from each other. There is more dispersion than in picture C. So the problem is nature of interrelationship between two given variables is more or less linear in both diagrams. When both are linear, in C and D, both are linear, then we have to measure the linearity which is more intense in side diagram C or in diagram D. So we can see here that diagram C has more intense towards linear relationships, while in diagram D there is a lesser relationship between linearity. It is also linear, but the intensity of linearity is somewhat less. So from scatter diagram, we are getting the picture of the nature, that is, it is linear or non-linear, or degree, whether it is linear, how much linear it is. So purpose of scatter diagram is we measure the nature, that gives us about idea about the interrelationship between two variables, like straight line relationship, non-linear relationship, etc. Whereas degree is giving us the extent of the relationship, that is how much linear. So I have completed the scatter diagram portion. Now I am considering the correlation part. Correlation. What do you mean by correlation? There is a relation in this definition or in this subject. Correlation. Correlation is the characteristic by virtue of which two variables are interrelated under a bivariate setup. That is, I have two data points like x and y, or something else, height and weight, marks in mathematics, marks in statistics, etc. So correlation is the measurement which measures the interrelationship between two variables x and y. So correlation is the characteristic by virtue of which two variables are interrelated under a bivariate setup. Now simple correlation. Simple correlation is the characteristic by virtue of which two variables are linearly interrelated. Most important point, that linearly interrelated under a bivariate setup. So correlation means that we consider all those relationships, whether there is a non-linear relationship, whether there is a linear relationship, or etc. etc. So correlation measures the relationship between two variables, whereas simple correlation measures only the linear relationship. That is, after I have done simple correlation on a data set, we are getting only whether it is linear or non-linear. But in correlation, we are getting the relationship. That is, if there is any relation between those two variables, whether maybe that may be linear or non-linear. But in correlation, I am getting the point that it is linear or non-linear. That's not the point. I have getting that if the two variables are interrelated, whereas in simple correlation my objective is to only find the linear relationship between two variables. So correlation is a more general term, whereas our simple correlation is only figured out in linear relationship. And in our class 12 syllabus, we have only simple correlation to study, so no need to worry about correlation right now. We are telling everything from here will be simple correlation. Maybe I consider it as a correlation there, since there is no other correlation from now on. So as in our syllabus, so types of correlation. What are the types of correlation? So positive simple correlation, negative simple correlation, and zero correlation. So in the previous example, in the very first class, I have told you that height and weight, as height increases, weight also increases. That is, there is a relationship of friendship, as in my friend also told you last class. And if negative simple correlation means there is an enmity in this data sets, and zero correlation, there is no relationship of correlation. That is no relationship whether x do everything, I have nothing to worry about. So there is three types of correlation. Positive simple correlation means, like I have already told you, the facts of heights and weights. If height is more of a person, then it is considered as in general weight is also be more. And similarly, if height is less, then it is assumed that weight will be also less compared to other things. So here, as x increases, y increases or decreases on an average. That is, if x increases, y will increase. And in general, the most important term is on an average. On an average means that in general we are getting the thing that in, you can see in the point x is more less here, x is more here, but corresponding to that y value it is less. But in general we are getting that this is straight line like structure and having a positive slope. So here x increases and y increases in general, and then on an average. So if you this comes to in your paper or in your examination, you have to write on an average, because it is most important now that we are not taking the any particular data point, we are taking the on an average data set. We are considering the data set on an average, and here x as it increases, y increases on an average, and simultaneously as x decreases, y will decrease on an average also. So in the next example, negative simple correlation, that means there is an enmity between two variables. That is, if x increases, y will definitely decrease, and if a y increases, then x will have to definitely decrease. That is in general. That is not all those x's having more value, y will have to be less value. But here, as x increases on an average, y have to decrease on an average. That is, you are getting that there is a negative slope of, if you consider it as a straight line, we have to get there is a negative slope. So here, as x increases, y decreases on an average, and as x decreases, y increases on an average. And lastly, what is zero correlation? Zero correlation means there is no relationship. You can consider it as a circular step. That is, if we consider the lowermost value of x, they are corresponding to having similar x values, and for that similar x value of or above here, if you consider it as a straight line structure, you can get 2 points here in the in the below and in the above. So for a particular x value, we are getting that y value, less y value, and more y value. That is, and this is the not only for 2 points, we are getting that all those points having the same structure. That if x increases or decreases, there is no relationship of y to be increment or decrement. That is, here x as in x increases or decreases, y remains constant on an average. So from these three types of correlation, I have previously told you 3 examples. So you can understand which is what. So I am telling you that if height and weight, then there will be a positive simple correlation, that height increases, weight increases. In negative simple correlation, industrial production and lockouts, that is, more the lockouts, if I consider x as the number of strikes and lockouts and y be the industrial production, so more the lockouts or more the strikes, less will be the industrial production, and less the x values, that is less the number of lockouts, more will be the industrial production. So this is the example of negative simple correlation. And what is zero correlation? Zero correlation means there is like marks in mathematics and your shoe size or your height. There is nothing to worry about your marks in mathematics, just considering your height. So if you have less height, you can get marks of 60, and similarly you have a greater height, you can also get the same marks. So there is no relationship of height in mark to the marks of mathematics, so there is a zero correlation relationship. So from, I have already told you the scatter diagram portion, correlation portion, simple correlation, and types of correlation. Now we are getting into the most mathematical part of the syllabus, or most important part of correlation coefficient, like what is product moment correlation coefficient or Karl Pearson's coefficient of correlation. So you can see here that this is consider it as a graph paper. There is so many points, like consider it 8 pairs of observations on x and y. This is a scatter diagram having two axes. If you consider those axes removed from this is nothing but a scatter diagram. So Carl Pearson's motive was to consider that if I consider this is kind of a positive type of relationship, that is, it is more or less linear and it's having a positive slope. And now what Carl Pearson do in this calculating coefficient of correlation, he considered the graph paper into four first different quadrants, like first quadrant, second quadrant, third quadrant, and fourth quadrant. You have already learned it from, I think, class 7 or 8 geometry, or more precisely class 11 trigonometry. You have already know what is first quadrant, what is second quadrant, what is third, and what is fourth. So here comes a question: what is our origin then? So here Pearson considered the origin as x bar and y bar point. So since we have x data sets, so and y data sets like univariate model, we have got the marginal distribution from this bivariate frequency distribution, and from that we can easily consider the arithmetic mean of x and arithmetic mean of y. So from that we get getting that x bar and y bar. So why x bar and y bar will definitely be between in this point since it is average at all. So x bar and y bar, we are selecting that particular point and consider it as origin. So as if it is origin, we can without loss of generality can consider y bar equals to 0 and x bar equals to 0. So nothing to understand right now about that. So what we are doing that there is some we have just divided the whole data sets into four parts. That is, there is some data sets in first quadrant, there is some data set in second, some in third, and some in fourth. So what we define now, we are considering two new variables, x dashed and y dashed. What is x dashed? X dashed is x minus x bar. That is the data set data points of x having dispersion from those vertical line. That is, what is the dispersion from x bar? So x minus x bar is considering the dispersion from the x bar line, all those data sets, if this is the x point, xy points, then x having behind is in the left side of the x bar, so x minus x bar will be definitely negative. Similarly, it is x having x bar, x is in the right of x bar, so x minus x bar will be positive. So you can understand what I am doing right now. So x dash equals to x minus x bar, y dash equals to y minus y bar. Now consider product of xi dash to yi dash. Xi dash to yi dash means xi minus x bar into yi minus y bar. So it is positive in quadrant 1 and positive in quadrant 3 and negative in quadrant 2 and negative in quadrant 4. So what does it mean? We are considering the product xi minus x1 and yi minus y bar. That is, we are considering the dispersion from those means, and we are considering that it will be positive in first and third quadrant and second and fourth quadrant. How is it possible? So consider it a particular point. I am showing my cursor here. Let us consider this one point. This is above from our y bar line and right from our x bar line. So x minus x bar is positive here and y minus y bar is also positive here. So the product will be positive in this case. So all those points in quadrant 1 will yield positive results. That is, we always get x minus x bar and y minus y bar positive, and simultaneously the product will be also positive in quadrant 1. In similar example, quadrant 2, we have all those data sets which have above from the y bar line, but it's from in the left from the x bar line. So we have understanding that y minus y bar may be positive, but x minus x bar will definitely give us negative results, and so on. The product will be also negative. That is, plus into minus will always give us negative results. So second quadrant will yield us the product value negative. First quadrant will give us positive value. Similarly, in the third quadrant, we can see that x values are left from the x bar line and y values are below from the y bar line. So x minus x bar will give us negative results. Y minus y bar will also give us negative results. That is, I am shifting the arrow towards and I am telling that these are negative points. So x minus x bar will be negative and y minus y bar will be negative. But when I consider it as a x minus x bar and y minus y bar product, I am getting that negative product negative will be positive. That is, in third quadrant we are getting positive results. Similarly, in fourth quadrant, x bar is left from all those x points of this data set in fourth quadrant, but y values are below from y bar value. So similar likewise in second quadrant we have y minus y bar is less than 0 and x minus x bar is a positive value. So x product will be negative also. So is it clear? I think it's clear that product will be positive in quadrant 1 and quadrant 3 and negative in quadrant 2 and quadrant 4. Now, I have considered that Carl Pearson have give us a measurement about covariance. Covariance means we are getting the relationship of those two variables, 1 by n summation xi minus x bar into yi minus y bar. That is, we are just summing up or adding up the product values. So adding up the product values, what will give us? Adding up the product value means that it measures the dispersions of this data from this particular point, or x bar comma y bar. We are getting those data points. Now I have written here that covariance of xy, it is the sum of the product, and I have taken the average of that. That is covariance of xy equals to 1 by n summation xi minus x bar into yi minus y bar, as we are already done in our mean or dispersion. So xi minus x bar, now we have to consider only the x minus x bar into yi minus y bar portion. So covariance is xy is greater than 0 if positively correlated, less than 0 if negatively correlated, and 0 if no correlation or uncorrelated. So what does it mean? Covariance is xy is greater than 0 if positively correlated. Positively correlated means you have already learned that positive simple correlation means that this is positive slope. Negative simple correlation means this has to be a negative slope, and no correlation means there is nothing to tell about slopes. So in this figure, I have considered tell you that if the data points is more in 1 and 3 quadrant, we will get more positive results, and 2 and 4 will give us negative results. So consider it as a positive simple correlation. You can understand in this figure, this is positive simple correlation. If it is positive simple correlations, then you have more data points in 1 and 3. You will see the results of positive results, like in one quadrant and in third quadrant we get positive more results. So when we adding up, we are getting 1 and 3 or giving more positive values, whereas 2 and 4 is giving us less positive values. So adding up with all those 4 quadrants, we will get up with some positive results. But in case of negative correlation, if I consider x bar y bar, like here I have putting my cursor there, if I consider x bar y bar point there and divide the whole thing into 4 quadrant, so we are getting that quadrant 2 and quadrant 4 having more values compared to the quadrant 1 and quadrant 3. That means quadrant 2 is giving up the product value negative, and quadrant 4 is also giving up the product value negative, but quadrant 1 and quadrant 3 is giving us the product value positive. But since there is more data points in quadrant 2 and quadrant 4, we are getting that negative results. Similarly, if no correlation, there is everything in the like in quadrant 1 having the same data like quadrant 3 more or less, or quadrant 2 and quadrant 4 as similar results. So in general, we are getting that if there is no really linear relationship between them, then covariance xy equals to 0, since all those balance out each and every one. So this is covariance of xy. Now, drawbacks of covariance, or more precisely drawbacks of the products, sum of the product summation xi dash yi dash. We have xi dash equals to x minus x bar and yi dash equals to yi minus y bar. So there is two defects. If I considering the sum of those products, then we are getting two defects. That is, it depends on the number of pairs of values of variables. Like I consider 20 people of your locality and 200 people of some other locality. Then I am getting that collecting their data sets, and then I have calculated the means of their height and weight. Again, same example, height and weight. I am getting that xi dash and yi dash will give us the number or value, like say 200. 200 height into 200 semi into kg. This is I am getting from summation I xi dash yi dash from 20 people. Whereas if I consider the 200 people, we will definitely get more value, since there is no number of variables is more in there. So obviously magnitude will be higher from this, but it doesn't imply that these have more relationship than this locality, or there is lesser height and weight relationship, a linear relationship between 20 pairs of values rather considering the 200 pairs of values. So defect one is it depends on number of pairs of values of variables. So we have to consider it as in a unit measurement, like I have to divide it by n, since n is the number of variables. So remedy one is by dividing n, we can remove the effect of number of pairs. That is, we can consider that is the magnitude as a standardized version. That is, whether it is 20 or whether it is 200. If I divide by n, we are getting the standardized magnitude value. So there will be a it can healthy comparison between those 20 data points and 200 data points. And the defect 2 and most important defect, that it depends on units of measurements of variables and also on variability. Variability means that it depends on height and if I consider xi points as a height and yi points as kg, so we are getting summation I xi dash yi dash as being a unit of centimeter into kg. Similarly, if I getting something as like your expenditure and your income, so if I consider those, then your result will yield in the unit as the rupees square, rupees into rupees. So in general, we don't do something that is not special for each one example and special for another example. This is not like statistics. So what we do here, we have to consider this measure unit free. So what we do here, by dividing Sx and Sy, we can remove the variability present in the product term. You are already familiar with the standard deviation and x and standard deviation of y. Even standard deviation, what is the measurement of standard deviation? It measures the dispersion from the data points available. So it measures the variability present in the data point. So if I divide, if my problem here is summation I xi dash yi dash having the problem that it has a variability issue. So if I divide it by the measurement which measures the variability, then we can get rid of that. So remedy 2 is by dividing Sx and Sy, we can remove the variability present in the product term. So there Sx is standard deviation of x and Sy is standard deviation of y. So now the product moment correlation coefficient between x and y, which is suggested by Carl Pearson, it's Rxy. It is the definition of the product moment correlation. We say it as Rxy, which is 1 by n summation I equals to 1 to n xi minus x bar into yi minus y bar by standard deviation of x and standard deviation of y. So there is the two remedies, 1 by n, that is we divide it by n, and standard deviation of x and standard deviation of y. So what we are getting from here, the results we will getting unit free measurement, that Rxy is unit free. Since SDX, if I consider x as a height data and y as a weight data, then xi minus x bar will give us in centimeter result, yi minus y bar in kg result. Similarly, SDX and SDY will give us results in respectively in height, that is in centimeter and in kg. So if I divide these two things, we will get a unit free measurement having no variability present in the data, having no variability interrelationship between two data. And this 1 by n summation I equals to 1 by n xi minus x bar into yi minus y bar is already referred as covariance xy in the previous page. So now you can see that what is our correlation coefficient? Our correlation coefficient is equals to R covariance of xy by SDX into SDY, where covariance xy is 1 by n summation xi minus x bar into yi minus y bar, and SDX equals to root over 1 by n summation xi minus x bar square, SDY equals to root over 1 by n summation yi minus y bar square. So Rxy is a measure of nature and degree of linear interrelationship between x and y. So we are measuring the nature, whether it is linear or non-linear, is it having a positive slope or negative slope. It is mostly in linear relationship, whether it is linear relationship or no linear relationship, and if whether it is linear, that is degree, is it positively correlated or is it negatively correlated. If it is positively correlated, then how much it is correlated. So we are measuring those things. Consider some problems in our next class. So we have to see some properties. If we consider any definition or any term we introduce in statistics, we will do some analysis of that things. That is some, we will definitely do some properties. So one is correlation coefficient is a unit free measure. It follows from definition that I have already told that covariance xy will give results in units of x and units of y, and SDX is giving unit of x, SDY is unit of y. So cancelling each out, Rxy is a unit free measurement. Property 2, correlation coefficient is a symmetric measurement, that is Rxy equals to Ryx. That is now from the definition of Rxy, we are considering Ryx, that is 1 by n summation yi minus y bar by SDY into xi minus x bar by SDX. But multiplication since follows of commutative rule, we will get that xi minus x bar into yi minus y bar is nothing but yi minus y bar into xi minus x bar. So multiplication since follows commutative rule, we are getting that rxy equals to ryx. So there is no problem with these two properties. Now property 3, the magnitude of correlation coefficient is independent of change of origin and change of scale. You can definitely do something in practical or in your central tendency practical or in your dispersion practical, that we have to do something origin and scale change for considering the our practical computation easier. So what if I do here also, that if I getting the correlation coefficient, if I getting the data of 200 points like height in 170 to 190 centimeter, 150, weight in 60 to 80 kgs. So in computational process, you have to do more calculations, more spurious calculations, and it will give you some you can mistakenly do something wrong thing, and the whole problem will be just cancelled out. So what we do in a getting the data point in a small variable, that is we are taking always the observations. If we can consider some origin change or some scale change, then we can consider it as a lower set of values. So suppose if we are doing those things like in practice, we have done in practical of central tendency and dispersion. So if we do the same thing again, whether my correlation coefficient will be depends on that. That is, I have to consider it as a new problem or something. Every something problem will be happening there. No, the magnitude of correlation coefficient is independent of change of origin and scale. So let us prove it. Suppose x1, y1, x2, y2 are the and so on x and y, and denote the n pairs of observations on two variables x and y. Now we are considering two variables u and v. U is equals to x minus a, where a denotes the origin change and c denotes the scale change, and v equals to I minus b by d. B is origin change and d is scale change. So now considering the example 0, a, and this is x, total distance is x. Now considering that I am going to Mumbai from Kolkata, so 0 point is Kolkata. Distance x will cover the Mumbai distance, and I am going via Hyderabad. Say the Hyderabad point is saying my A point. So let us consider that Kolkata to Mumbai have a distance of 4,000 kilometers, and Kolkata to Hyderabad have 2,500 kilometers. So if I consider the whole distance Kolkata to Mumbai, so if I tell him that 200 people are going from Kolkata to Mumbai in bike or in motor car, so if they are going via Hyderabad, we are getting that x points is showing us the total distance, whereas a to x, that is showing the Hyderabad to Mumbai distance. But this doesn't affect the whole journey. So x minus a, if I change the origin, the shifted from 0 to something a, there will be no problem. So where a, b, c, d are constants, and similarly this example is valid for y and b also, and c comma d not equals to 0. It is obvious that if I consider u equals to x minus a by c, and if I not restrict c to be 0, then if c is 0, then u will be undefined, and similarly for the same case for b. So I have to consider c comma d not equals to 0. You have to write this very precisely in your examination paper if this comes here. So you have to write that a, b, c, d are constants taken by us. C comma d not equals to 0, and a, b denote change of origin, and c, d denote change of scale. Now we are doing some computational process. So u equals to x minus a by c. So x equals to a plus u, and from I think you are very familiar with this for all I notation. So since I have the data points in data points of x, that is I have x1, y1, x2, y2 denote in pairs of observations on two variables x and y. So if I have the relation x equals to a plus cu, we have all those points xi equals to a plus cuy. So we can consider the mean, that is by dividing, taking the whole sum and dividing by a, we are getting that xy equals to a plus c. And similarly, Vx, it already depends on only the scale change, not the origin change. You have already done some properties of dispersion in your class 11 class. So I am not writing here the whole procedure, and this is saying that Vx is equals to c square into Vu. And similarly, standard deviation will be modulus of c into standard deviation of u. I have nothing to say why modulus here, since you have already know this. Similar case for y equals to b plus db, and y bar equals to b plus d bar, and b range of y equals to b square into b. Standard deviation of y is modulus of b into standard deviation of b. Now, covariance of xy. What I have to calculate, I have to measure that the magnitude of correlation coefficient. Magnitude of correlation coefficient can be measured by the fact covariance. I have written here that Rxy is equals to covariance of xy by standard deviation of x and standard deviation of y. So if I have to measure Rxy, we have to measure covariance of xy and standard deviation of x and standard deviation of y. So we are doing here right now. So we are considering the covariance of xy. Covariance of xy means 1 by n summation I equals to 1 to n whole product of xi minus xy into yi minus yy. Now considering xi values like what have I done here, that xi equals to a plus cuy minus x bar, that is a plus cu bar into b plus db bar dbi minus b plus db bar. So I am getting that 1 by n summation I equals to 1 to n c into ey minus u bar b into vi minus v bar. So cb into covariance of ub. That is covariance of xy equals to cb into covariance of ub. This is my first result. Now I am getting that, and I have the standard deviation of x equals to modulus of t standard deviation u, and standard deviation of y is modulus d standard deviation of b. So now I have calculating the Rxy. Rxy means covariance of xy by standard deviation of x into standard deviation of y. So covariance of xy, I am getting that CD covariance of uv, and standard deviation of x is modulus c standard deviation of u, and the standard deviation of y is modulus d standard deviation of v. So I am getting that again CD by c bar c modulus c and modulus d. I am taking this apart. What I am getting rest, that is covariance of uv, standard deviation of u, and standard deviation of v. From the definition of correlation, what I am getting from covariance uv by standard deviation u and standard deviation of v, that is it measures RUV, that is it measures the product movement correlation coefficient of u and v variables, that is Rxy equals to Cd by modulus c into modulus d into RUV. Now consider two examples, two sets of examples more precisely. If C and D are of same sign, that's both positive or both negative. For example, like C equals to 2 and D equals to 3, then I am getting that CD equals to 6, and modulus of C is equals to 2 and modulus of D is equals to 3, that is product of modulus or modulus will be 6. So CD by modulus of C into modulus of D will getting me one result 1. Similarly, if C and D are of both negative sign, that is C equals to minus 2 and D equals to minus 3, again I am getting that C equals to 6, and modulus of C equals to 2 and modulus of D equals to 3, that is CD by modulus of C into modulus of D will give me result 1. So in this example, in this previous measurement, we have getting that Rxy equals to CD by modulus of C into modulus of D RUV, that is if C and D are of same sign, this balance out, that is it getting 1, and we are getting that Rxy equals to RUV, this relation 1. And if C and D are of opposite sign, like that C is positive and D is negative, or vice versa, like C is say 2 and D is minus 3, then we are getting CD equals to minus 6, but modulus of C is 2 and modulus of D is 3, so we are getting the ratio of the product will be minus 1. So from those above result, we are getting that Rxy equals to CD by modulus of C into modulus of D into RUV. But since we C and D had of the opposite sign, we are getting that result 1 minus 1. So Rxy equals to minus of RUV. So considering the relation 1 and relation 2, we can combining both. We can say that modulus of Rxy is equals to modulus of RUV. That is, magnitude of correlation coefficient is independent upon change of origin or scale. That is, we have nothing to deal with those origin change or a scale change. Like if I consider that my product movement correlation coefficient is in the whole data set be 0.7, say. So if I getting the origin and shift change, we are getting that RUV will also be either 0.7 or minus 0.7, but it will definitely not shift from the value 0.7. That is, magnitude is not affected by the change of origin and change of scale, and the direction or the thing is happening here in the change of sign. We have to consider the C and D, whether we are taking the same sign or opposite sign, and in the practical problems we have to do if same sign, then we have don't worry, but we have opposite sign, then we have to consider it more precisely, and we have to consider Rxy equals to some CD by modulus of C into modulus of D into RUP. In general, Rxy modulus value is same as the modulus value of RUV, that is magnitude of correlation coefficient is independent upon change of origin or scale. So now what we have done in this class, we have considered the very quick recap of bivariate data and bivariate frequency distribution and marginal distribution. Then we have learned today the scatter diagram portion. What is scatter diagram? Then we are come to the correlation part. Correlation means simple correlation in your class 12 syllabus. Then types of correlation. What are the correlations? Simple correlation, positive correlation, negative correlation, no correlation. Positive correlation means the and slope is positive, and if negative correlation, slope is negative, and in zero correlation there is no need to talk about slope. Then we are considering that correlation types. Then we have told that product moment correlation coefficient or Gall-Pearson moment correlation, that we are defined that correlation part. So why we are doing that RXY part? Since we are getting the scatter diagram, we are getting that we are having a precise idea whether it's linear or non-linear, but the scatter diagram is for linear layman people or non-statistician, that we are getting the results of this is linear or this is non-linear, this is positively linear, example, but etc. But we cannot get any further idea from scatter diagram. That's why we have to do product movement correlation coefficient, like you have already done in all types of statistical definitions or statistical measurements, that we are not only limited to diagramical presentation, we have to do analytical presentation and we have to do further analysis. So that's why we have measured the RXY term, and in the next class, today's time is getting over. In the next class, we will do the rest properties, and maybe one property is left here of RXY, and we will definitely do some problems in the next class. So I think we are done with today. So thank you for listening to the class. I am stopping this right now. So good night, everyone. Maharaj, I have done this, so I am closing my.
অভিরূপ শেষ করে দাও, টাইম হয়ে গেছে। এক সেকেন্ড শেষ হয়ে গেছে নাকি? আচ্ছা এখানে একটা হয়ে গেছে না, সরি আমি আচ্ছা বন্ধ করে হ্যালো 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 ওকে
মানি কাজেস
হ্যাঁ আছে,
চেক করে নে।
দেখিস তো একটু বোর্ডটা আসছে কি?
মানে 1 মিনিট হোল্ড করো, মানে 1 মিনিট হোল্ড করো।
হ্যাঁ আমি একটু চেক করে নিচ্ছি একটুখানি, তোমরা তো?
হ্যাঁ হ্যাঁ
হ্যাঁ বলছি বোর্ডটা ক্লিয়ার আসছে তাহলে?
হ্যাঁ হ্যাঁ ক্লিয়ার আছে,
সাউন্ড
সাউন্ডও ক্লিয়ার আছে। স্টার্ট করতে বলে করে দিস,
হুম
অসুবিধা নেই।